Let me make sure my settings are right because sometimes my settings be off. Okay, this right. All right, class. So today is October the 3rd. We're right on time. October the 3rd. The agenda it goes as follows. We should have already written our homework in our planner. We should have already completed the warm up. I'm going to go over the warm up. Okay, I've already checked your homework. I'm going to give you about 15 minutes to complete the group assignment. Shh, somebody is talking. Let's stop doing that, okay? If you have a question, just raise your hand, okay? Any questions? So we're going to finish the group assignment first, literal equations, okay? You're going to turn that in for a grade. Then we have some notes that we're going to do, teacher directed notes. And the notes today in our interactive notebook are going to be on functions and function notation. Okay? If we have time, then we'll do some guided practice type things. If not, then we'll do guided practice tomorrow. All right, let's look at the warm up. Here on the warm up, it says, given the following functions. All right, these are the functions here. We're going to find x, okay? We're going to find x when g of x is negative 5. All right, when a function is written in function notation, this is what this means. A regular equation is written in this way, and please write this on the bottom. Y is equal to 2x plus 1. I'm going to zoom in a little bit so you can see it. Where your input is the x, your output is going to be the y. And what that means is that I substitute a number in for x and I get an output value for y. Okay? When I write an equation in function notation, please write this down. This is what that looks like. My x now becomes f of x or g of x or c of x, a number of x. So I'm going to use the common one. I know that y is the same as saying f of x, and f of x is the same as saying y. Miss Reyes, what does that mean? That means that you have to know or have to have a value for x to get an answer for y. Okay? So whatever number is in the parentheses is a value for x. So to write this equation in what you call function notation, you replace y with f of x or g of x or h of x. Doesn't matter what variable you use most people use f because f is function. You can use any letter you want. I really try to refrain, of course, from using x because that's confusing. All right. But you can use any other letter. I wouldn't use O. I wouldn't use S because those numbers look like letters. Okay. Yes.
So like you just like write F and you put like the value inside the
That is correct for X. Okay. All right. So to write this equation in function notation, you replace Y with f of x or g of x or h of x. I'm going to use f of x for now. So I write this as y, sorry. I write this as f of x is equal to 2x plus 1. This equation is written in function notation. Okay? All right. And we're going to write notes about that today. Okay? All right. So now, excuse me. So now, number one, this is saying find x. What is the value of x when g of x is negative 5? That means when y is equal to negative 5, what is x? Because g of x, f of x, h of x all represents y. So what is the value of x when y is equal to a negative 5? So this is the one that has g of x in it. So let's look for when y is negative 5. Y is negative 5 here. What's the x value? Y is -5 here, sorry. What's the X value?
0.
It is 0. So X is equal to 0. Let's look at number 2. This is saying that X, you see the number in the parentheses is X. This is saying that X is equal to 4. What is Y? So look for f of X. Which one of these is f of X? The first table. So let's look for when X is 4. X is 4 here. What's the Y value? 2. So X, well, I'm sorry. I did it backwards, didn't I? Sorry. Oh no, yeah. X is, I said it backwards, but I did it right. X is equal to 4. My Y value is 2. Ooh, my head's itching. All right. Try number 3 on your own to see if you can get number 3. Try number 3 on your own to see if you can get number 3. All right. Do we have ideas?
Not yet.
Not yet. Okay. I'll pause real quickly. Give us a chance to think. All right, good folks. Look at it. H of X is the same as saying Y. So Y here is equal to 0. So they want to know what X is when Y is 0. So what? Let's find when Y is 0. Look at the Y. Let's find where Y is equal to 0. Look at the Y axis where Y is 0. Okay, Y is 0 right here, isn't it? What's the X? What's the X value? -3. Okay. Now let's see if you can do number 4. I'm going to pause for the calls to see if you can do that one. So this is telling us that X is equal to what? -6. So let's find -6 on the x-axis. -6 on the x-axis is this 1, 2, 3, 4, 5. This is 6, right? And so we go. This is where x is -6. So what's this? 5. Y is 5. Y is 5. Raise your hand if you got that right on your own. Okay, good deal. All right, we're gonna practice it, so don't worry. Please put this in your folder, and I need you to take out your Lord, what am I saying? Literal equations investigation sheet from yesterday. Literal equation sheet from yesterday. Let me pause for the calls. It looks just like this. Please make sure that your name is on the sheet. If you don't have this sheet, please raise your hand. The timer, I'm going to set the timer for 10 minutes. Okay. I want you to work very diligently with the persons at your table. Okay. Does anybody not have a teammate? All right. Everybody does. Okay, good. All right. Let's work. I'm set the timer for 10 minutes. Let's do it. Each other, please. Okay. Look. Sorry, Emma. All right, guys. Let's look at the very first one. It says, which equation shows the bricklayer's formula correctly for H? Well, we have an equation, and the equation they give you is N is equal to 7 times capital L, capital H. We're solving for capital H. What do we do in order to solve for capital H? Raise your hand, please. Michael?
You have to do inverse operations. Division.
Okay. Divide by what?
You have to divide by
And 7. 7L. So when we divide, yes, baby. Yeah, you're after Renee. You have to wait. You can go first. All right, so okay, that's fine, but not right now. All right, so we got 7 over. I'm sorry, N over 7L is equal to what? H. What letter is that?
D.
Okay, a wall is 20. Shh, Asia, y'all ready? A wall is 20 feet long and requires, um, bless you, 1,470 bricks to build. How high is the wall? So all you're doing is substituting. Any questions about how to do that? Substitution. So when I substitute for I'm substituting for H. I'm going to replace N with what number? What am I replacing N with? Very good. 1,470. And then 7 times, what's L here? 20. And we're going to solve that. Okay? The other, we're solving for N. I know. We're solving for N. So let's solve for N here to predict the number of chirps. So let's write that out. We got T is equal to 50. We got plus N minus 4 divided by 4. All right, good folks. Somebody is talking. Let's stop doing that. Okay, so we want to get N by itself. What are we going to move first? 50. How do you move 50? Minus 50. This is going to give us T minus 50. We're solving for N, babe. It says solve for N. Because that's this. Okay. All right, so now 50 is gone, and we are left with N minus 4 divided by 4. So now what are we going to do to get N by itself? Multiply both sides by 4. So that's going to remove that, and I'm left with the numerator, N minus 4 on this side. On this side, when I distribute, I have 4T minus what? What's 4 times 50? 200. Now what are we going to do to get N by itself? Add 4. So what does that give me on this side? 4T minus what? 296? No, not 296. Say again. Negative 196. That's okay. Okay. All right. So now number 4, it says the formula for the area. Okay. I'm going to check this to see if you got the right answer. So I'm not going to give that to you because I want to take that. And then I want to see what we came up with here. Well, actually, let's just do this one. Raise your hand if you put that it is a literal equation. Raise it high. Raise your hand if you said it's not a literal equation. Okay, I want you all to tell me why you think it's not a literal equation. Shh. Come on. Shh. Somebody is talking. All right, so technically, both parties are right. If, in fact, if you substitute the number for pi and replace it with an actual number, it is no longer a literal equation. But as it is here, it's a literal equation because there's more than one variable. You can make the argument either way. Any questions, comments, or concerns? All right, please put your name on the paper and stack it on somebody's tabletop and take out your interactive notebook so we can take some notes. This is page 23. Pause for the cause. All right, again, if I lose you, please raise your hand so that I can clarify what I'm saying. Okay. All right, this is page 23. In the corner, we got quarter one, Q1. This is page 23. We're going to be talking about function and function notation. When we start talking about functions, the first thing that we start talking about is a function table. Before we start saying anything about what is a function, function notation, and all of those things, the first thing that we start is by talking about function tables. So that's the part we're going to cover first is what does a function table look like. So let's do function tables. This is what you first learned when you were in 5th, 6th grade. If you didn't, pretend that you did. We have X and Y, where we call our X values, or we put our X values here. We put our Y values here. We say these are our input values. We sometimes say these are our output values. We even sometimes say that these are our domain values. And our Y values are our range values. And then we'll also learn that our Y values can also be called f of x or g of x or h of x and so on and so forth. Please write that down, that these are synonyms for x. These are different ways to say x. These are different ways to say y. The meaning of x could be our independent variable. So we're going to put that here. The meaning of y could be our dependent variable. In parentheses, I'm going to put meaning of x. In parentheses here, I'm going to put meaning of y. When we graph what's in our table, we use what you call a coordinate plane. And in many cases, our coordinate plane, we use the first quadrant. Sometimes we'll use other quadrants, but most of the time we'll use the first. Our horizontal number line is called our x-axis. Our vertical or up and down number line is called our y-axis. And this again is a coordinate plane. So we got different names for x, we got different names for y. Our x values could be called x values, input, domain, independent variable. Our y values can be called y values, obviously, output, f of x, or dependent variable. Any questions so far? A set of ordered pairs is a relation. Bless you. Relation. Relation. Relation is a set of ordered pairs. A function, oh, let's put what is a function, because that is one of your essential questions. A function is where your x values do not repeat. Where the x values of a relation, a set of ordered pairs, do not repeat. Doesn't say anything about y. Doesn't matter if y repeats. So now we're going to do some examples. You're going to tell me, is this a function? Yes or no. Function, not a function, okay? First example. We're going to do a set of ordered pairs, which is called a relation. Function or not a function? Please write that down. And why? Oh, am I talking to? I can't. Shh. Silas, what's wrong, baby? Oh, ignore. Yeah. Yeah, go ahead. All right. Raise your hand if you think this is a function. Raise your hand if you think it is not a function. Okay. This is a function. Look at your x values. When the x values do not repeat, let's look at all the x values. This is the x value, x value, x value, x value. Do any of these x values repeat? No. Okay. This is a function. This relation, set of ordered pairs, is a function because the x values do not repeat. The x values or the domain values do not repeat. Okay? Any questions? Let's do another one. Number 2. Okay. Let's do this one. All right. Raise your hand if you think this is a function. Raise your hand if you think this is not a function. Very good. This is not a function. Why is this relation not a function, Silas? Very good. Which x value repeats? 2. We got 1, 2, 3, 2 again, and then 5. This relation is not a function. This relation is not a function because it's two twos, right? 2, 2. Because the x value 2 repeats. You good? Shh. Guys, shh. I don't. Number 3, try this one. Remember. Well, no, I'm just gonna. Thank you, babe. All right, so look at this. Shh. Please write if it's a function, not a function, and why. Please write function, not a function, and why. All right, let's raise our hand if we think this is a function. Raise your hand if you think it is not a function. Very good. Why is it not a function?
Because the number 4 repeats.
Because the 4 repeats. All right, so this relation, hush, this relation is not a function because the x value 4 repeats. Number 4. Remember, this is a table, but it's still a relation because it's a set of ordered pairs. But this set of ordered pairs is arranged as a table. I cannot say that this table is a function table because it's not a function. I can only say it's a function table when the x values do not repeat. So this would just be a table. It would not be a function table. Any questions about that? Let's try this one. Hush. Yes, baby. Okay, please hush. All right, we got 2. That's very disruptive. Seriously, it's disruptive. Okay? Don't interrupt my class for foolishness. Okay? Relation or not a relation? Let's write that in, and then why or why not. Function, sorry. Function or not a function. It is a relation, sorry. Remember, how this is written is mapping. The ordered pairs are written in what you call mapping. The ordered pairs here are written in table form. Okay? Let's write out the ordered pairs for this mapping situation. What is the first ordered pair? 2, 2. What is the second ordered pair? 3 and -1. What is the third ordered pair? 4, comma 3. What's the next ordered pair? 5 and 1. And what is the last ordered pair? 5 and 3. Very good. Okay. From that list or that relation, raise your hand if you think this is a function. Okay. Raise your hand if you feel like this is not a function. Okay. Very good. This relation is not a function. Why is this relation not a function? Yes. Because there are two x values that are 5. This relation is not a function. Yeah. No. Doesn't matter which one you write first, okay? This relation is not a function. Hush. Come on, y'all. This relation is not a function because the x value 5 repeats. Any questions? Do you understand? Thumbs up, I get everything so far. Sideways, I'm confused about a couple things. And upside down, I don't understand any of it. Please vote. Shh. Hush. Christian. Shh. All right, here we go. All right, so now let's do function notation. Any questions about what is a function before we move to function notation? Oh, good. Thank you. Shh. All right. Function notation. Shh. Function notation is another way to write an equation. Star. How, Miss Reyes? What is the other way to write an equation? It is another way to write an equation by using f of x, g of x, h of x to express that x is a function of y, okay? Using f of x, g of x, h of x. Refrain from using, like I said, please refrain from using letters that look like numbers. It's not wrong, but it just looks confusing. Okay? Such as 0 or the O. Refrain from using an O instead of an F. Okay? Refrain from using an S, even though you might see an S, but it looks like a 5. Don't confuse yourself if you have a choice. Use letters that are definitely different from numbers. Will you might see an S? Yes, you might see an S, okay? But just note that if you see an S, it is not 5. They're not going to put a number of of X, okay? Unless they're trying to multiply that number times X, then it's not function notation. Any questions? Yes, baby. What's your question? Dennis, did you have a question? Okay. What was your question?
Is this gonna like apply in the real world?
Yes. Shh. I'm not. If I told you now, you wouldn't understand. So let's wait till we get there. Yes, baby. Yes. Shh. If there's time. All right, here we go. Shh. You were supposed to go earlier. You didn't go. You forgot. You're supposed to be after him.
I told you. He said if he could go, not said he could go before me.
Oh, okay. I got you. All right. Okay. So yeah, just go when he comes back. All right. Function notation. So now Remember, you are replacing f of x or g of x with y. They are equal to each other. The number that's in the parentheses is the value for x or input.
Are you gonna grade our notebook?
All right, yes, the notebook is worth 35% of your grade. All right, here we go. If I have, let's do example, okay? Function notation. To write this equation in function notation, you would say y, let's write the equation. Y is equal to 5x plus 2. I'm going to write it in function notation. That means I'm going to replace my y with f of x or h of x. So here, instead of putting y, I'm going to put f of x is equal to 5x plus 2. You do not always have to use x either. It could be another variable, okay, in the place of x, okay? It's still going to be considered as the input, all right? I would refrain from using y because that's usually the letter that we use for output. Any questions? All right, let's try this. Let's suppose that we have n is equal to 4w minus 7. See if you can write that in function notation.
I'll put the game to first grade.
No. Somebody already asked me.
Oh, you have to take this.
All right, here we go. We're going to replace n or y with f of x or g of x. But instead of putting x, what variable did they use here? W. So we're going to put f of w is equal to 4w minus 7. Shh. Let's do one more. Shh, please stop, baby. Don't say anything.
We not T.
Then use the next page, baby. Write that in function notation.
Yes, I don't think we should use T.
Shh. Shut your face. All right. Can someone tell me what the function notation will be, Robert? H of V. Very good, babe. And you can use H, G. You can use any letter here, okay? Plus, what you say, baby? 12V. Perfect. Do you understand? All right, let's please put this up. Shh. Please make sure